Okay, so in our first lesson in Math 20-2 in our quadratic section, we're going to just talk about what a quadratic function is. So a quadratic function will form this, what we call a parabola. So it's like a curved type of line. A quadratic function also should be written in the form of ax squared plus bx plus c. So really, probably the most important thing for you to know here is that you should have a degree of 2 on any quadratic function. Some other important characteristics of a quadratic function is it will have a domain of any real number unless there's a context, like let's say your x represents time or something like that, but all of our quadratic functions should be a domain of any real number. They should have a range that's dependent on the max or min point. So if you look at this quadratic function I have here, it has what we call a min point because it has a minimum or lowest point on the graph. If you had a quadratic function that opened downwards, it would have what we call a max point. So our range will depend on where that max or min point is. From here, quadratic functions have one turning point. So one place, which is what we call the vertex, where the graph changes direction. A quadratic function will have either 0, 1, or 2 x-intercepts. So an x-intercept is where our graph crosses the x-axis. So just to draw it for you, if I had a quadratic function with 0 x-intercepts, okay, this could be a possibility. Maybe it opens up and it never crosses the x-axis. So that would be 0 x-intercepts. I could also have a quadratic graph where maybe the turning point is on the x-axis. So that would be an example where we have 1 x-intercept. Most of the graphs we're going to look at will cross the x-axis at 2 places, so they will have 2 x-intercepts. All right, no matter how we draw a quadratic function though, it should only have 1 y-intercept or else it's not a function anymore. So let's look at example 1 after we talked about what a quadratic function is. So are these quadratic functions? You could press pause on the video, try all 4, and then press play and see if you got them right. So in this first example, yes, it is a quadratic function because it has a degree of 2. So any equation that has a degree of 2 would be a quadratic function. Over here, yes again, because although I'm missing that constant term, like I don't have a -9 or a +5, I still have a degree of 2, so this is still considered to be a quadratic function. Okay, and then over here, no, because if you look, we actually have a degree of 3, so it's not a quadratic function. And then the final one, no, because here we actually have a degree of 1. So when we don't have an exponent, a degree of 1, we did that in 10C. That's a linear function. Okay, so that's a lot of terminology that we threw at you there, but don't worry, we're going to go through it a little more. So quadratic functions, as I mentioned earlier, form a parabola. So that parabola can open up, and when it opens up, like in this pink diagram, the vertex is called the minimum because it's the minimum point on the graph. It could also open down like the green diagram. If your parabola opens down, we have a maximum point. So the vertex is always the turning point, and it'll either be a minimum or a maximum. So a general rule of thumb, if a, so a is the coefficient in front of your x squared, is positive, your parabola opens up. And again, a parabola that opens up looks like this. If a is negative, your parabola opens down. So again, it would look like this. We don't really need to know about b, but it does change the location of the symmetry of your graph, but there's not too much that we will get asked about b. c is pretty important though. So when we're in expanded form, so meaning we don't have any brackets, Our C value is our y-intercept, so that will show up quite a bit. So if you're like, what is a y-intercept? It's where our graph crosses the y-axis. So I'm going to draw you a picture. Here's our y-intercept. It's where our graph crosses the y-axis. Okay, so example 2, using what we just learned here. So it says determine the value of the y-intercept and state whether a is less than 0, so that means a would be negative, or where a is greater than 0, meaning positive. So if we look at this first example here, we can see that the graph opens upwards. So if our graph opens up, a has to be positive. So if a is positive, that means a is greater than 0. Our y-intercept is where it crosses the y-axis, which we can see here is at -3. So my y-intercept would be at -3. All right, let's move on to the second graph. So in this example, you can see the parabola opens down. So because the parabola opens down, that means that a is less than 0. Our y-intercept is right here at 3, so we would say the y-intercept is at +3. All right, let's move into example 3. So now in example 2, we looked at a graph to determine if we had an a value greater than 0 or less than 0. Now we're going to look at the equation and try to figure out if the parabola would open up or down. So in this first question here, we have a positive 10x squared. So because it's positive, that means that my graph would open up. Our y-intercept is always our constant. So in this case, our constant is -9. So that means I have a y-intercept of -9. Let's move on to the next example. Here, I have an a value that's greater than 0. So I would say my graph opens up because a is greater than 0. I don't have a y-intercept. So this would be the same as if you were to add 0 at the end. So if you don't have a constant, that means your y-intercept is actually 0. Moving on to example 3. This is actually, I should have fixed your notes. I'm just going to write it down here because originally I didn't have a quadratic. So in your notes it says 4 minus x squared plus 3x. So in this case, we tried to trick you by writing the terms in a different order. But your leading coefficient is the -8x squared because it is whichever term has the degree of 2. Here we have a negative leading coefficient, a negative a value. So that means our graph would open downwards, our parabola. Our constant in this case is the +4, sorry, so our y-intercept is +4. Moving on to the last example. Our -3x squared is our leading coefficient. So because we have a -3 in front of that x squared, that means our graph opens down. My y-intercept is the constant, which in this case is 9. Moving on to example 4, this is a multiple choice question. Which of the following quadratic functions has a maximum point? So if it has a maximum point, right, let's draw a picture here. Here's a parabola with a maximum point. That means it would have to open down. If it opens down, it would need an a value that's negative. It'd be less than 0 or negative. So right away we know both a and b are wrong because they both have positive a values. So we need a negative a value, so it has to be c or d. If we read the rest of the example, it says we need a negative y-intercept. So the y-intercept is the constant. So the only example that has a negative y-intercept is C because it has a y-intercept of -4, while D has a y-intercept of +12. So the correct quadratic function that has a maximum point and a negative y-intercept is C. Last question. Which of the following statements describes the graph of a quadratic function f at x equals ax squared plus bx plus c? So in this case, in order to end up here, the graph opens up and has a positive y-intercept. Oh, it looks like we're actually missing the rest of that question. Okay, well, I will pause the video at this point then.